Hello everyone, this is the third lecture on the topic interpolation. The first and second lecture on interpolation is already uploaded in this channel. Let us start the third lecture. Now, when we approximate a function by a known function, then there must be an error term because the approximation is not exact. So, when we approximate a function f(x) by a known function phi x, then there must be an error term or an remainder term. We can derive the error term. So let us start. Let f(x) be a function such that its analytic form is unknown. But the value of f(x) are given for given set of n plus 1 distinct values of x, say x0, x1 up to xn. Here we also assume that the function f(x) is continuous and differentiable sufficient number of times. That is, we assume that f(x) is continuous and differentiable sufficient number of times. Now, let phi x be the interpolating polynomial of degree n at most. Since the value of f(x) are given for n plus 1 distinct values of x, so the interpolating polynomial, that is the degree of the interpolating polynomial, is n at most, such that f of xi is equal to phi xi for I is equal to 0, 1, 2 up to n. This is equation 1. That is, f of x0 is equal to phi x0, f of x1 is equal to phi x1, and up to f of xn is equal to phi xn. Now, let our n plus 1x be the remainder or error term in approximating f(x) by phi x. Hence, f of x is equal to phi n x plus Rn plus 1 x. This is equation 2. That is, the exact form of fx is equal to approximate form of fx, that is phi n x, plus Rn plus 1x, that is error. Therefore, Rn plus 1 x is equal to f of x minus phi n x. That is, Rn plus 1, put x is equal to xi, that is Rn plus 1 xi is equal to f of xi minus phi n xi. Now since f of xi is equal to phi n xi for I is equal to 0, 1, 2 up to n, therefore Rn plus 1 xi is equal to 0 for I is equal to 0, 1, 2 up to n. This is equation 3. F of xi is equal to phi n xi from the equation 1. Since x is equal to xi satisfy the function Rn plus 1x, therefore x minus xi are the factors of Rn plus 1x. That is, x minus xi are factors of Rn plus 1 x for I is equal to 0, 1, 2 up to n. Hence, we can assume Rn plus 1x is equal to psi x into the factors, that is x minus xi, that is x minus x0 into x minus x1 into up to x minus xn. This implies Rn plus 1x is equal to psi x into omega x, where omega x is equal to x minus x0, x minus x1 up to x minus xn, and Rn plus 1 is equal to psi x into omega x. This equation is equation 4. Now, let us take an arbitrary fixed point x dash which is distinct from x0, x1, xn. Now, let x dash be an arbitrary fixed point which is distinct from x0, x1 up to xn. Now, from 2 we get f of x is equal to phi n x plus Rn plus 1 x. Now put x equal to x dash, we get f of x dash is equal to phi n x dash plus Rn plus 1 x dash. This implies f of x dash is equal to phi n x dash plus we know that Rn plus 1 x is equal to psi x into omega x. Therefore, Rn plus 1 x dash is equal to psi x dash into omega x dash. This is equation 5. Now, we consider an auxiliary function capital F of x given by capital F of x is equal to small f of x minus phi n x minus psi x dash into omega x. This is equation 6. Now, capital F of x dash is equal to small f of x dash minus phi n x dash minus psi x dash into omega x dash. That is, we put x equal to x dash in the function capital F of x. This equal to, from equation 5, we get f of x dash is equal to phi n x dash plus psi x dash into omega x dash. Therefore, f of x dash minus phi n x dash plus psi x dash into omega x dash, that is, this is equal to f of x dash from 5. Therefore, this equal to 0. That is, capital F of x dash is equal to 0. And capital F of xi is equal to, that is, put x is equal to xi, small f of xi minus phi n xi minus psi x dash into omega xi. Now, we know that from 1, f of xi is equal to phi n xi for all I is equal to 0, 1, 2 up to n. And omega x, we know that omega x is equal to x minus x0, x minus x1 up to x minus xn. That is, product of I is equal to 0 to n x minus xi. If we put x is equal to xi, we get omega xi is equal to 0 for all I is equal to 0, 1, 2 up to n. That is, omega xi is equal to 0. So, this is equal to 0. F of xi minus phi n xi is equal to 0 minus psi x dash into 0. Since from 1, small f of xi is equal to phi n xi, that is, small f of xi minus phi n xi is equal to 0, and omega xi is equal to 0 for all I is equal to 0, 1, 2 up to n. This is equal to 0. That is, capital F of xi is equal to 0. Hence, capital F of x vanishes at n plus 2 points. That is the points x0, x1 up to xn and x dash. Now, since small f of x assumed to be continuous and differentiable, and phi n x and omega x. Since phi n x and omega x are polynomials, so they must be continuous and differentiable. That is, phi n x and omega x are polynomials. Hence, continuous and differentiable. Now we know that capital F of x is equal to small f of x minus phi nx minus psi x dash into omega x. Now since f of x, small f of x, phi nx and omega x are all continuous and differentiable, therefore capital F of x is also continuous and differentiable. So capital F of x is continuous and differentiable. Now, by repeated application of Rolle's theorem, we get capital F in plus 1th order derivative at the point xi is equal to 0, where minimum of x0, x1 up to xn and x dash less than xi less than maximum of x0, x1 up to xn and x dash. Now, capital F of x is equal to small f of x minus phi nx minus psi x dash into omega x. Now, differentiating n plus 1 times, we get n plus 1 times derivative of capital F of x is equal to n plus 1 times derivative of small f of x minus n plus 1 times derivatives of phi nx minus psi x dash constant into n plus 1 time derivatives of omega x. This implies if n plus 1 times derivatives of capital F of x is equal to n plus 1 time derivatives of small f of x minus, since phi nx is a polynomial of degree n, therefore n plus 1 times derivative of phi nx is equal to 0 minus psi x dash into, since omega x is a polynomial of degree n plus 1, so n plus 1 times derivatives of omega x is equal to n plus 1 factorial. Now put x is equal to xi, that is implies n plus 1 times derivatives of capital F of x at the point xi is equal to n plus 1 times derivative of small f of x at the point xi minus psi x dash into n plus 1 factorial. This implies by repeated application of Rolle's theorem, we get n plus 1 times derivatives of capital F of x at the point xi is equal to 0. Therefore, this equal to 0. Therefore, 0 is equal to n plus 1 times derivatives of small f of x at the point xi minus psi x dash into 1 n plus 1 factorial. This implies psi x dash is equal to n plus 1 times derivatives of small f of x at the point xi divided by n plus 1 factorial, where minimum of x0, x1 up to xn and x dash less than xi less than maximum of x0, x1 up to xn and x dash. Now from 4 are n plus 1 x dash is equal to psi x dash into omega x dash. This implies Rn plus 1 x dash, putting the value of psi x dash, that is n plus 1 times derivative of f of x at the point xi divided by n plus 1 factorial into omega x dash. This implies Rn plus 1, since x dash is arbitrary, therefore Rn plus 1 x is equal to omega x into n plus 1 times derivative of small f of x at the point xi divided by n plus 1 factorial, where minimum of x0 up to xn and x less than xi less than maximum of x0 x1 up to xn and x. This is the required error term. That is all for today. If you like our classes, please do like, share and subscribe our channel for more classes. Thank you so much.